Energy consumption needs are expanding rapidly around the globe in the recent decades. Indeed, there are many reasons behind this enthusiasm, such as the increase in population as well as the rise in commercial and industrial activities. To meet these needs and satisfy the clients at different levels, recourse to new energy sources, along with the construction of new infrastructure for the transmission, is therefore essential. This point encouraged the exploration of new lines of research in the field of transport, protective systems and production of electrical energy. Regarding the latter, new long-term ecological strategies have been adopted around the world. It consists of a gradual integration of clean energy sources into electricity networks. Energy is a complex process as it is possible to convert it into different forms, transport it, store it in some forms and use it in various end-use modes in innumerable kinds of places. Appropriate transport and distribution systems are needed either for direct use or for further conversion into other useful forms to supply various places of consumption. It is well known that the electrical energy is produced, transported and distributed in high-voltage transmission networks. Transmission is mostly conducted in alternating current HVAC. In fact, this type of transport is not always the best practical way when it comes to interconnecting renewable energy sources with grids. The resources of these energies are often located in remote regions such as at sea, in uninhabited areas or even in desert regions. For this purpose, transmission in direct current HVDC is recommended under such circumstances. In general, electricity from centralized power generation is more appropriately transmitted over distances with different lengths by transmission and distribution networks. In order to fulfill the safety limits and requirements, every element within the electricity system such as pylons, overhead lines, substations etc. should be designed in accordance with the relevant national and international standards. The electrical energy, from generation to consumption, passes by multiple adaptations where different levels of voltages may be required. Step up and down of the voltage level is set up through the electrical substations. Voltage level from high to low, or the reverse, is basically carried out within the electrical substations so it is suitably delivered to customers. These substations can also perform any of several other important functions such as measuring electric power qualities and connecting communication signals. In this light, various types of substations are developed to meet the requirements of the customers. These types usually depend on the voltage level, which depends on additional factors like the number of the customers supplied. Indeed, other parameters will be affected by the selection of the voltage level, including the size of the substation and the protective systems. Take an example of United Kingdom. A route length of more than 7,000 kilometers of overhead lines represent a part of the UK electricity transmission system, including about 700 kilometers of underground cable and more than 300 substations. Basically, a substation includes different components where the main one is the transformers, used to adjust the voltage levels. This can be achieved by changing the voltage levels between high transmission voltages and lower distribution voltages, or at the interconnection of two different transmission voltages. Substations generally have switching, protection and control equipment, including measurement and monitoring equipment. Circuit breakers are usually used in large substations to interrupt any short circuits or overload currents that may occur on the network. Additional protection measures should also be considered such as surge arrestor and fuses for protection of distribution circuits. Figure shows a simplified representation of an electrical substation. As can be seen in this figure, different protection measures should be considered in this system to protect both individuals and equipment. In general, high-voltage installations require an effective earth termination system in order to protect people against excessive step and touch voltages. As shown in figure, all metallic parts are earthed to prevent accidental contacts by workers with energized elements. In addition, a layer of surface material gravel in figure of high electrical resistivity is usually used in substations. This layer can help in limiting the body current by adding resistance to the equivalent body resistance. Risk in substations. During the lifetime of substations, there are many different sorts of faults and hazards that can occur. In most cases, the causes of these malfunctions are related to weather conditions such as lightning strikes, fog, rain and snow, solar heat, windborne materials. Pollution within the substation should be considered since it can engender a flashover on the high-voltage insulators pollution of the insulating surface. Indeed, it is obvious that the common cause of damage consists in the aging of the equipment and/or the degradation of the insulation material. These causes can result in several significant issues. The electrocution for anyone entering the perimeter of the substation is the one with the high risk because it can occur with or without physical contact with equipment. In the same context, different elements put individuals in danger if they are inside the substation, such as electrical conductors, high voltage lines entering the substation, high voltage busbar, capacitor banks, battery rooms, circuit breakers, metal component inside the substation. Most of the energy companies are actively monitoring how the networks are working. They are well placed to evaluate the vulnerability of the networks to weather impacts. Different monitoring systems have been developed to provide a way to monitor lightning activity that can be harmful. For instance, Jupiter OLS is a site-specific, high-speed video-based lightning location system that detects 100% of lightning return strokes and pinpoints the location of lightning strikes with unprecedented accuracy. This active monitoring system and many others should be designed to help plan and prioritize the work to enhance the resilience of the sector to current weather events. Furthermore, oil-filled switchgear and transformers as well as any other regulators and capacitors need to be fully isolated and grounded. Protective earthing system: anyone standing near the fault location can receive a dangerous electrical shock owing either to the presence of a dangerous potential difference between the earth and a metallic object that a person is touching or resulting from the potential gradient on the earth's surface. Figure illustrates a graphical representation to show the step and touch voltages. It should be noted that the step voltage is the potential difference, on the earth's surface, that is experienced by an operator bridging a 1 m distance without contacting any earthed structure. By analogy, the touch voltage is the potential difference computed with respect to the surface potential where a person could be standing while at the same time having a hand in contact with an earthed structures. Metal-to-metal touch voltage usually occurs when metallic objects or structures within the substation site are not bonded to the earthing system. For safety and protection intentions, designing a safe protective earthing system is mandatory to provide the shortest path to the effective flow of fault currents without exceeding the operation and equipment limits. In this light, a couple of national and international standards as well as regulations and rules have been published to identify the requirements of the earthing design and to define relevant parameters for structures, electrical equipment, and systems. Among others, table gives example of standards proposed for the said matter. These standards offer the necessary guidance and recommendations for the design, specification, inspection, and periodic testing of earthing systems. It is worth noting that some standards and documents are indispensable for the application of the said standards. Engineers and designers should also take into account these guidance references such as BS 7430,